Hey, what's up, guys? This is Chung. So today, let's take a look at Codeforce problem, two platforms. And so the description is a little bit long here. I'll just scroll down to the bottom where we have like this kind of this picture where it's much easier to understand. So basically, we have like a bunch of points, right, with x, y coordinates, and then we also have like two platforms. Okay, two platforms with both whose both length is k, and we can put the platform at any y coordinates. And so after placing that platform on that y coordinates, basically it can save, right? So here it can be saved. All the points within the range can be saved, since all the points will start falling, and the so the points are within the range of the platforms can be saved. And our purpose is to find those two locations that we can put those platforms somewhere somewhere so that we can save the most points. And that's the description of this problem. And we have some constraints here. So we have like 2 times 10 to the power 4 test cases, and also for n and the k. So we have 2 to the time of 10 to the power of 5 n points, and also the length could also be this long. Okay. So yeah, sorry, the k is like within the integer size. Sorry. Yeah. And the x and y coordinates, they are also like within the integer value. Mm, yeah, so that's the description of the problem. I mean, so a brute force way will be what? We try all the possible locations to put those two platforms, right? Basically, we for all the, for all the x coordinates, where we have like a point, we'll try to place the platform on that, and to that's going to be O of n square, right? Time complexity to try all the possible locations for those two platforms. And And once we have put those platforms on the locations, we can use like a pre-sum like array to get the point, right? To to get the saved point by placing that platform on this location by within O1 time, right? So that's that. But still, since we have like this O of n square scenarios that we can for those two platforms, so this solution will still be a TLE. It will So which means that we have to find a better solution. And a common approach for this kind of problem is that, we can pre-process the maximum. We're gonna have like introduce a left pre-sum and the right pre-sum list, where the the left pre-sum I represents from left to I. What's the maximum? What's the maximum points we can save? Similar, similar for LP and for LPI. This means from I to n minus one, the maximum points we can save on the right side. So the reason we need to introduce these two lists here is that so that in the end we can just uh, traverse all the possible x coordinates, and we can just use the LPI plus RPI plus 1 to give us the maximum answer, right? The maximum like points we can save at the current ice location For example, this is the i's location. So because actually, so what this one tells us is we're gonna put like one platform on the left of I, and we're also going to put like the other platform on the right of I. Since we have already consumed pre-calculated the maximum of I of LPI and also the RPI plus one, then we can just say by using this like formula, we can just get the maximum all the possible combinations at i's location, right? For one platform on the left side and one platform on the right side. And also the reason we're doing an I plus one here is because all the points at the location I have already been saved by the first platform. And so that for the second platform we can just start from I plus one coordinates. So this way, instead of O of n square time, com time complexity, we can just consume all the possible uh, uh, platform combination P1 and P2 within O of n time. Yeah, and that's going to be our basic idea here. So and to do that, right, since we have bunch of the points here, so first I'm going to create a map to collect all the points for each of the coordinates. For example, if we have this one, we have 2 points, then in this map we're gonna have like at x1 we have 2 points, and here we have like the at x2 we have one point, so on and so forth. And since the map in C++ is already a sorted map, and then we can just process this point from left to right. And also, since we're going to calculate both the LP and RP, which means that to calculate the RP, we're gonna traverse from the end, from the right side, and the map is not a good data structure for that. So that in the second step, I'm going to convert this map into a vector, so that later on I can traverse this thing from the end. Yeah, I think that's the basic idea here. And so let's start coding. And to do the coding here, oh, and one more thing that I forgot to mention is that it's kind of obvious that the y coordinates for each of the points does not really matter. All we care is the x coordinates, because we can put the platform as low as we want. So it doesn't really matter how high or how low this point is. The only thing matters is the x coordinate, right? So to do that, I'm going to do a bunch of like the definitions. I already defined this maximum here, and also nk and xy. So like I said, so first I'm going to create like the int map to 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 group those points by the x coordinates, and then I'm going to read this n and k in, right? So for int I equals to 0 and I smaller than n, I plus plus, I rate x, and then I'm going to update the map, right? And here after this for loop, we're gonna have like the count, the count for each of the x coordinates. And even though we don't need the y coordinates, we still need to read that in because we have multiple cases we need to test. So here it doesn't really matter. I'll just read it into the Y here. So that's that. Okay. And so and after reading this the points into this map here, I'm going to create like a vector, right, to process those. And for the vector, since we need both the count and x coordinates for the later on for the sliding window logic, I'm going to for each of the elements in the vector, I'm going to use like a pair, right? So the pair is also the int and int. So I'm going to use a p here. And to populate the vector here, I'm going to need to iterate the map, right? So to do that, I need to create a like iterator for the map. Iterator for the map and call it it. So for it from the count dot begin, right? And then it does not equal to the count dot end, then it plus plus. And then for p dot push, right? Push back what we're gonna, since it's a pair, right? We need the iterator, the first and the second, right? We need both of those two values. Yeah, and that's now we have like a vector uh, with a pair element. So now the actual the size we care about is the size of this point of this vector, and then with this size we can create our pre-sum vector. It's going to be the int of the left pre-sum of the size, and also the right pre-sum of the size with the size here like this. And the next step is the try to calculate this two pre-sum list. So to start with, we have a left 0, right? Equals to what? Equals to p0 dot second. Okay, because here the p is what? P is the first one is the x coordinate. So basically at the x coordinate, how many points at this x coordinates? That's why at the first coordinates, right? And oh, again, so in this LP and the RP here, we don't care about the coordinates anymore because we'll be looping through from the left or right. So all we care is the count here. So at the beginning for the first one, it's going to be the count for at the first x coordinates, and then we start from L, right? L start from 0, and then we also need a current, right? So current is also like the p0 dot second, right? And then we start from 1 since we have already processed LP0. So the reason we start from 1 is that later on we'll be using the LP I minus 1 to calculate the current one. So that's why to prevent the index out of the boundaries, I will start from 1. That's why I pre-process. I set this LP0 separately. So now we have int r equals to 1, right? And then r is smaller than the size and r plus plus. So for each of the right pointer, right, we do a current, we accumulate the current count, which is gonna be the pr dot second, right? And then we maintain the sliding window. So which means that while the pr dot first, that's the x coordinates minus the pl dot first is greater than k, right? So then it means that we need to shrink the sliding window. So to shrink the sliding window, first we need to subtract the count from the current, right? Which is the left dot second. and then we do L plus plus, right? Now we have a valid sliding windows. We can just update our the the pre the pre-sum list, which is going to be the LP R, right, equals the max of the current dot LP R minus one, right? So so the value we saved in this LPR is the maximum, is the possible maximum point we can get, right? So similar for the RP. And so for RP, similar, like we do RP dots. We also pre-populate the first one, the which is going to P SG minus one dot second, right? Since we're traversing from the right side. And this time, right? This time we're gonna fix we're gonna loop through the left pointer, so which means that we're gonna so at the beginning, R is a size minus one, right? And the current is this one. Current is this one, and the for loop is like this. CR. So the for loop is int left, right, equals to n minus two, and the left is greater than zero, and left minus minus, and current similar like the P of L dot second. So the reason being is that for to traverse from the end to the beginning, right? The left is always moving, right? And that's why we at every time when we have a left, we accumulate the left, and then we'll try to shrink the right pointer. So while P dot R dot first, same, right? Actually, I'm going to copy these things here. They're almost the same. And the only difference is that we're gonna shrink decrease the right pointer, R minus minus. So here we're gonna have a left, right? And RP left uh, left plus one. Yeah, cool. So and then in the end, we just need to loop over go through the each of the index, and so but at the beginning, right? So we have a p0 dot second. That's going to be our starting point, right? The reason is that we're gonna loop through from 0 to I size minus 1, I plus plus. Okay, so this is because the like I said, right? So we have a current I here, and so we have a platform on the left side, and on the right side we on the right side the platform can start from I plus 1 because all the points from I have already been saved from I. That's why since we're going to do a I plus 1 here, that's why I stop from this size minus 1. And since if there's only one x coordinates, right? So if there's only all the points, they are all on the same x coordinates. So this p, this size will be 1, right? That's why we have to initiate the answer with the first element so that we can handle this corner case. And then we just need to do this max of the answer dot lp I, right, plus the rp I plus 1. Yep. And then just output. think that's it, right? The hmm. So let me run the code here. Okay, so let me find the test case. So copy this one, run. Okay. Did I make a mistake here? Like the which one? PL. Okay. Oh, here, I mean, it should be sides, not the n here. So we use the n instead of sides. Okay. Okay, so this time we have 6, 1, 5, and 10. Yeah, I think this time it's correct. Yeah, 6, 1, 5, and 10. Yeah, so that's basically the idea for this problem, you know, and for the time and space complexity, right? So uh, I think in my opinion, you know, of course, you know, all the rest to build these things, to build the LP and RP, and also to move to loop through in the end, they're all O of n. But we use a map here. So this map is like a sorted map, and we're inserting into this sorted map here, right? And if the worst case scenario, if all the points they all have the same, they all have the different x coordinates, to build this sorted map here, we're gonna need n log n time. So the total time complexity for this solution is also a O of n and log n, right? And space is just the O of n because we're gonna be storing using the pairs, the vectors, and the LP and RP to store some of the informations. Cool. I think that's it for this problem. And yeah, I mean, just to recap real quick, right? The So for this kind of problem, you know, especially when you want to make some improvements, uh, for basically for two of the moving parts, right? And a common strategy is to calculate to do a pre-process from left and also from right, so that later on you can just you can just e iterate each of the point, and then you can just cover all the possible scenarios given that one point for both the left side and right side. Yeah, I think that's something we need to learn, or we need to remember from this problem. And other than that, I'll stop here. Okay, thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.